at time sharing process once again, and we'll move on to real time process. Okay. So you know about batching or grouping. So how it is done, we have seen an example program for that. And second one is multi-programming systems, which means multiple programs. How do we execute it? Okay. Here, if you want to note down a few points here, you can just have a look at that multi-programming, how it is happening. So this multi-programming operating systems are developed to provide efficient resource utilization. Whenever you feel like the resources are not used effectively, so this multi-programming system is one of that. It's going to address it. Okay, and so this multi-programming operating system has many user programs. Let us say program 1, program 2, program 3, so on. So they are called as user programs. Where they are there, these users located at memory of the computer. Okay. Yeah. Hence the name multi-programming. I repeat again. A multi-programming operating system has many user programs in the memory of the computer at any time. Hence the name multi-programming. That's why we got the name multi-programming. So this has two modes. One is DMA mode and the other one is IO mode. Okay, it employs DMA mode of IO, input output. Okay, so we can able to perform input output operations of some programs while CPU is executing. Even though the CPU is executing, we are able to perform some input and output operations. Is that clear? So if you see this diagram, here we have three parts, A, B and C. So three of them are going to illustrate the operation of multi-programming operating system. So the operation of multi-programming operating system is given through this. Okay. So we have discussed this one, how the operation is going to perform in multi-programming, and it is being done to improvise the throughput. Okay. And we can allocate the priority for this. To discuss the priority allocation part. Yeah, here we discussed in the previous class. We'll recap that once again and we'll move on to time sharing process. Okay, so we observed that when we are trying to use multi-programming, we experienced that the throughput of the system is being increased. Okay, as you see this graph clearly. Okay, so degree of multi-programming is increasing from 1, 2, 3, so on. As the multi-programming degree is increasing, which means one program is executing, two programs are executed, three programs are executed, and the number of programs executed here, the degree of multi-programming will increase. On that, the throughput of the system is also increasing. Okay, so we experience the increase in throughput of the system. Fine. The final conclusion for multi-programming: when an appropriate program mix is maintained, which means we have n number of programs, we can use them effectively, can mix them effectively. We can increase in degree of multi-programming, which will result in an increase in throughput. So when we have n number of programs and we increase the degree of multi-programming, which will increase the throughput. That's what we observed from this graph. So variation of throughput with degree of multi-programming. When I increase the level of multi-programming, the throughput of the system seems to be increased. So it increases the performance improvement of the system. Okay, that's the conclusion of multi-program. Now let us look at time sharing systems. So time sharing systems is a very simple technique. So how do we understand that time sharing systems? Any idea about time sharing systems, anyone? Time sharing systems. Time sharing systems. Okay. So sharing systems, uh, we see that the time is constant for everyone. We cannot change that. Okay. But during that corresponding time, we can share the resources. So these resources can be shared in two methods. First one is by using a round robin technique, and second one by using what? You can see that here, time slicing. You can